What's up, guys, and welcome to this video on question 4 of the 2016 final exam. Yep. Okay, so this question is on Newton's laws. Let's get into it. So block A has a weight of 44 newtons and block B has a weight of 22 newtons. Block A is placed on a rough table. Okay, so we can see it's rough. That has a coefficient of static friction mu of 0.2. Block A and B are both connected via a light inextensible rope over a frictionless pulley, and block C is placed on top of block A as shown in the diagram. Okay, cool stuff. Everything we have, yeah. Okay, so determine the tension in the rope joining block A and B while the system is at rest. Okay, I also forgot this. So the system as shown in the diagram is only just at rest and on the limit of sliding, but it is at rest. Important. Okay, so question 4.1. Okay, I'm going to start off by drawing a free body diagram of block B. Okay, so block B has a weight which is equal to 22 newtons, and it's also got a tension of 22 newtons. Okay, so the block is stationary. No, sorry, it's got a tension T. Okay, so it's stationary, so that means the sum of the forces must be equal to 0. If we take upwards as possible, T minus 22 is equal to 0, so T must be equal to 22 newtons. Okay, so 22 newtons. And yeah, so we get 2 marks for that. We could have also done it using some inspection. Okay, so if we look at the pulley and we look at the rope, right, on the left hand side we have 44 newtons pulling it that way, and we have 22 newtons pulling it down. Okay, so this is the same as, let's say, a rope where we have 44 and 22. So how do we make these two equal? We add 22 newtons. Okay, so we could have done it by inspection, or we can use forces. Okay, question 4.2, define frictional force due to a surface. Okay, so question 4.2, I'm going to say is a definition. Okay, and the definition for frictional force. Okay, so the frictional force due to a surface is the force that opposes the motion of an object and acts parallel to the surface with which the object is in contact with. Okay, so basically, so that's the frictional force. It opposes the direction of the motion and is parallel to the surface. Okay, then it says state the magnitude of the frictional force required for block A to be at rest. Okay, so now I'm worried about block A. If I draw a free body diagram of block A, okay, so we have 4.3. If I draw a free body diagram of block A, we can see that that is tension, which is equal to 22 newtons. Okay, so yeah, 22 newtons. Okay, we have weight and a normal force, and we have force friction. Okay, the direction that I'm assuming is that it is going to be that way. So to the right is positive. So if I take the sum of the forces, it must be equal to 0 because it's stationary, and I'm looking at the right being positive. 22 minus the force friction must be equal to 0. So the force friction is equal to 22 newtons. Okay, and we only care about the magnitude, so we don't care about the direction, but if we did care about the direction would be left. Okay, cool stuff. Calculate the minimum weight of block C. Okay, so the minimum weight of block C to stop block A from sliding. Okay, so how are we going to do this? 4.4. Okay, so for question 4.4, we know that the frictional force, the force due to friction, is also equal to mu times the normal force. Okay, in this diagram, the normal force, if I'm looking at this diagram up here, in the diagram, the normal force is equal to weight, which is equal to mass times gravity, right? So, oh no, let's actually not do that, but let's say we've got the frictional force, we calculated that, that's equal to 22, we know what mu is 0.2, and so we care about the normal force. Okay, so the normal force is the only unknown here, so we can solve for the normal force, which is equal to 110 newtons. Okay, now back to the diagram. We saw that the normal force is equal to weight. okay? But in this case, we have the weight of A plus the weight of C. So we can say that the normal force equals weight A plus weight C. Okay, so we know the normal force is 110 newtons. We know the weight of A is 44 newtons. So we can add the weight of C. So the only unknown here is the weight of C. So we can solve for that, and we can say the weight of C is equal to 66 newtons. Okay, and yeah, we get 5 marks for that. Quite generous. Okay, moving on. Block C is removed from the system and starts accelerating. Okay, so we remove block C. Okay, so we remove block C. Cool stuff. State Newton's second law. Okay, so 4.5 is a definition, and it's a nice long one. So Newton's second law says that when a net force is applied to an object of mass m, it accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. So basically we get the equation F net equals ma. Okay, and we get 2 marks for that. Okay, so draw a labeled free body diagram for block B while it is accelerating. Okay, important, while it is accelerating. 4.6. Because we removed the weight, block B is going to go downwards now. Okay, so we can say that we have the weight of block B and we have the tension. Okay, remember that the weight is greater than the tension, and that's why it will go downwards. Remember, this weight is removed. So when C is removed, the system is going down. Okay. Yeah, so we get 2 marks for that. Okay, the magnitude of the acceleration of the system is 2.3 meters per second squared down. So the acceleration is equal to that. Calculate the tension in the rope joining the blocks. Okay, so 4.6, I'm going to use 4.7. I'm going to use Newton's second law. So F net is equal to mass times the acceleration. I am taking downwards as being positive. So we are going to have so we want to calculate the tension in the rope. So F net, so we're going to have weight, okay, minus tension. Okay, so weight of B minus tension is equal to mass times acceleration. Okay, but the mass, okay, remember the mass can be written as the weight of B divided by gravity times the acceleration. Okay, remember weight equals mass times gravity. So if we wanted to get mass equals weight over gravity. Okay, so this form is just easier for us because we don't know what the mass is. So to calculate the tension, we can say that the tension is equal to, taking the tension to the right hand side, we're left with the weight of B minus the weight of B divided by gravity times the acceleration. So we have the weight of B was 22 minus 22 divided by 9,8. The weight of B times the acceleration, which was given as 2,3. Okay, so the tension can be calculated as 16,84 newtons. Okay, and I think we care about the magnitude here. Okay, calculate the frictional force acting on block A while it is accelerating. Okay, once again, let's start off with a free body diagram. So we have tension pulling that way, and we have force friction. We also have weight and the normal force. Okay, but we only care about the horizontal direction, so I'm going to use F net, Newton's second law once again, is equal to mass times acceleration. Okay, so I'm going to take the right hand direction as being positive. So then we have tension minus the force friction is equal to mass. I'm going to write again as the weight of A divided by gravity times the acceleration. Okay, remember this system, because B accelerates at 2 meters per second, A must also accelerate at 2 meters per second because they are connected by this rope, right? So what I'm left with is, I know the tension, I just calculated it, minus the force friction is equal to the weight of A, which was 44, divided by 9,8 times the acceleration, which was 2,3. So I can say that the force friction is now equal to, let's see, there's only one unknown here, so I can solve for that, and it's equal to 6,51 newtons. And that's the final answer. Okay, important to note that the frictional force is now less. We have a frictional force of 22 before. Okay, and I think that is the last question. So question 4.9, state 2 reasons why the frictional force between block A and the surface is smaller than the value calculated before. Briefly explain. Okay, so 2 reasons. What are the 2 reasons? Okay, so this is a theory question. Okay, firstly, we know that the normal force is less because block C has been removed. Okay, and remember the frictional force is dependent on mass. So if we remove mass, then we will decrease the frictional force. And secondly, we can say that the block now experiences kinetic friction, which is less than static friction. So mu k is less than mu s, which is static friction. Okay, and that gives us 2 marks each, giving us a total of 4 marks. Okay, cool stuff, guys. I hope that wasn't too difficult. I hope I made it easier if it was difficult. Yeah, so we have 26 marks in, I don't know, less than 26 minutes, so I'm happy with that. So cool stuff, guys. Thanks for watching, and in the next video we will continue. Cheers.